Hi folks, thanks for stopping by. I'd like to talk today about the height of the sun using the Flat Earth model. This sketch is shown on the Flat Earth Wiki site. It says, Volova and scientists prove different theories from the same phenomena. Now, what we're going to see today is that the Flat Earth model is contradictory and really disproves itself. Now, the sketch shown here works like this. If the sun is seen at 45 degrees when you're 3,000 miles from the equator, that's when on the equinox, when the sun is over the equator, and the Earth is flat, then the sun must be 3,000 miles high. And there's no question about that. Now, Minneapolis, Minnesota, it's almost exactly 45 degrees north latitude. And it's 3,096 miles from the equator, according to dateandtime.com. Now, this puts the sun about 3,000 miles high, assuming that the Earth is flat. Now, I want to go over latitude a bit here, because we just used it to calculate the height of the sun, and I'll be using it throughout this video. Latitude is the angle from the vertical to the sun, taken at midday on the equinox when it's over the equator. Latitudes of locations are used to draw maps, and then they're used by navigators to read the maps and find the locations of things like cities and mountains and whatever. Now, when you see latitude coordinates on maps, this means that at that location, this is the angle the sun is seen at from the vertical when it's over the equator. Now, we just found the sun to be about 3,000 miles high using the Flat Earth model. But is the Earth really flat? We haven't proved that yet, and at this point we're really just assuming facts that are not in evidence. If it's flat, we should get consistent numbers for the sun from any location. Now, this would conclusively prove that the Earth is flat. Case closed. And not flat if the numbers were inconsistent. So, this is my formula. The height of the sun equals the distance to the equator divided by the tangent of the latitude. Now, I went ahead and computed some of this data from some cities around the world, and it's all shown here on this page. And the thing that sticks out here is that last column, the height of the sun. As you can see, there's no consistency, and the height of the sun just keeps getting bigger and bigger the closer you are to the equator. Now, that tells you right there, there's something wrong here. This sketch shows a scale drawing of that data, the data from my chart. As you can see, there's no consistency about how high the sun is. The lines all crisscross. It's kind of a tangled mess. Now, if the Flat Earth model was correct, the sketch should look like this. The sightings from different cities should all converge at one point. That's where the sun is. And this really debunks the Flat Earth model because it puts the sun at different heights depending on where it's viewed from. The closer you are to the equator, the higher the sun is by Flat Earth logic, and there's no way that can be true. So, we got a problem here. Now, either the Earth is not flat, or the distances from the cities to the equator, they must be wrong. So, I want to try a different method, one that doesn't use the distances to the equator. Now, this method uses an extra triangle, but I'll spell the whole thing out. What I want to do is find the height of the sun, and this just takes two steps. First, the distance to the sun is calculated with an oblique triangle. Side A will be the distance to the sun. That's what we want to get out of this triangle. Side B will be the distance between two cities, for example, New York City and Montreal, and the angles will all be derived from the latitudes. Then with side A, the distance to the sun, known, solving for the height over the equator and the distance to the equator, it's easy with a simple right triangle. Now, New York City and Montreal, I chose these because they're really close as far as the longitude. That's east and west. they're within a half a degree of longitude, and that's pretty good. Now, this distance between them, this is the hardest step, so I'm going to tackle that first. Now, Montreal to the equator is 3,148 miles according to debunks.info. New York City to the equator is 2,816 miles, and the difference between them is 332 miles. Now, I wanted to double check that with Google Transit, and the number that Google Transit plus MapQuest, they both give 372 miles as the driving distance between these two cities. Now, you know that the driving distance isn't a perfectly straight line. And looking at this map, I can believe that there's an extra 40 miles consumed in this wiggling around, so I think I'm going to use the data from dateandtime.info, and I feel good about that because it's consistent with the data from Google Transit. So, New York City, it's at 40.71278 degrees north, and Montreal is at 45.5 degrees north. So now I've got numbers to work with, so let's put them on a sketch. I'm looking for side A, that's the distance to the sun. Angle A, which is opposite side A, is 90 plus the latitude of New York City, or 130.71278 degrees. Side B, which is New York City to Montreal, is 332 miles, and angle B, which is opposite side B, is the latitude of Montreal minus the latitude of New York City, or 4.78722 degrees. This page shows the data that I used at the top and the results of the calculations at the bottom. You can pause the screen and look that over. Now, I used the same method for Nashville and Birmingham, which are also north and south of each other, similar to New York City and Montreal. And I'll skip the explanation and just jump right to the data. The top part of the screen is the data that I used, and the bottom part of the screen is the numbers that I derived using that data. Now, this next page is a summary. This thing shows all the data, and one thing that just sticks right out here is that the height of the sun, as seen from Nashville, it's double the height of the sun as seen from Montreal. And New York City and Montreal are, according to this, south of Birmingham. So, I don't know, that maybe puts them in the Gulf of Mexico. And Birmingham and Nashville, you could look at it the other way, maybe they're north of Montreal. So that puts them up in Canada. Doesn't make a whole lot of sense. So this next sketch, it's a scale drawing of how the data lays out. I think you can see there's a big problem here. If the flat Earth model was correct, there'd only be one sun in the sky. The sightings from the different cities would all converge at one point. That would be the sun. And it looks just as bad as the other method. Now, one thing to note here is that latitudes are used to draw maps. And a map that was drawn using flat Earth logic would be completely useless. Now, you can use this method in this video to calculate the height of the sun from any two cities, and you're always going to get a different number. There's only one thing wrong with this method. The problem is not the geometry, the algebra, or the trig. Okay, the problem is the Earth isn't flat. Everything would work out just fine if it was. If the Earth was flat, it would be so easy to prove. And this would be the method that you'd use. You just triangulate the sun from two known points. Done deal. You got the height of the sun. Now, if you can repeat that number from different cities around the world, case closed. I mean, if you could do that, I'd be in the flat Earth camp. But it's not happening. Now, it doesn't matter what flat Earth model you use. Round, square, diamond, pork chop, or banana peel. If it's flat, you could reconcile that with the sun. But there's no way. And it's not like we don't know where the sun is. The positions of the sun throughout the year is extremely well documented. It has been for centuries. We know where it was, and we know where it's going to be. There's no mystery to be solved about where the sun is in the sky. And it's right there on every map that shows latitude. The mystery is, why do people think the Earth is flat? So to sum this thing up, what we've seen here is that the height of the sun, it can't be found assuming that the Earth is flat. This conclusively debunks all flat Earth models, in my opinion. You ever notice how in all these flat Earth videos, the flat earthers always come up with a different number for how high the sun is? That tells you something right there. Now, this flat Earth idea, it's a fantasy. This thing was like dreamed up as if the globe model was like a conspiracy to keep people stupid. Really? No irony there. Well, I guess that's about all I got to say right now. Thanks for watching. It was kind of fun to make, and please check out my other Flat Earth videos. They're kind of cool. And I'll see you next time.